Alrighty, welcome back to the last video on trig about solving problems that have multiple triangles. These are the ones that are a little bit more complicated. Picture looks a little intimidating because of how much the stuff is in it, but really it's just using the skills you've already mastered so far. Okay, they are often multi-step, so they won't be ones that you can just do one trig ratio and take you straight to the answer. Usually there's two, sometimes there's three things that you have to do. Okay, it's usually best to start with the triangle that you know two things in. So if I look at this one down below, I know an angle, I know a side length. Now I'm just going to highlight that triangle. Okay, that one in orange is the one we know two pieces of information in. You can see angle B is 47. The side length from the bottom, its opposite side is 4.2. If you look at the other triangle that isn't highlighted, the only thing you know about it really are just two angles. Now those won't really help you finding the side length, because if you only know one angle, you need another side length to help you out. Now the most important side in a scenario like this is going to be the side that both triangles share. Okay, if we could find that one highlighted in orange, then we know something about both triangles. So using the, let's say the triangle highlighted in red here, using that, we should be able to find that one that was in orange, so its hypotenuse. If I look at angle B, I know its opposite side is the one across from it, so that's 4.2. Really, I'm looking for the hypotenuse here. Now that hypotenuse is the hypotenuse of both triangles. We need to find that in order to help us do this. So let's say that if we're going to use opposite and hypotenuse, that ratio is going to be the sine ratio. So we have the sine of some angle being equal to opposite divided by hypotenuse. Fill in the stuff you know. I know I have an angle of 47. That'll be our reference angle. So the sine of 47 degrees is equal to the opposite side to it, which is 4.2. And you're going to divide that by the hypotenuse, which in this case, let's call it side length BD. Okay, this is again is one of those cases where you don't need to use the inverse trig function since you know the angle, so you're going to divide it by 1. Okay, you can do the cross multiply bit, but since that variable is on the bottom, we're going to essentially be dividing here to get to our side length. So we'll do 4.2, multiply it by 1, divide it by sine 47. So in your calculator, you're going to do 4.2, divide it by sine 47 degrees. That'll give us our hypotenuse. Now, we aren't totally done this question, so I don't really want to round this answer. Okay, I need to use it somewhere else. So let's go find out what it is first. 4.2 divided by sine 47. I get a big long decimal here. So BD is equal to 5.74, and then there's a whole bunch of other numbers. Now there's a way you can actually store that number, all of it, to use it in future calculations. And that button you're looking for is right above on. So it says store. Okay, so what you could do is you could actually press it and assign a letter to it. So alpha, it'll be the button that you're going to press to assign it to a letter. Let's just assign it to A. So if we press store, we're going to then assign that answer to A. So if I press enter then, it's going to tell me the same thing. So if I just put A into my calculator and hit enter, I should get the same number with all the decimal places. Yeah, it's going to save us a bit of time when we go to use that number somewhere else. Okay, so now I have that number stored in my calculator. So we've got to go take a look at the other triangle in this scenario to find what I actually have to find. So I need to find out what C to D is. Let's call that, let's just keep it CD. Okay, so there's side length C to D. I have a reference angle that I could use to help me here. Let's use pink. So there's my reference angle in pink. Opposite to it would be BC. I don't know anything about it, and I don't really care. I don't need it. CD is going to be the adjacent side. And I just found out what the hypotenuse was. It was that 5.74 number, which we stored in our calculator. If I'm going to use adjacent and hypotenuse here, that's going to be cosine. So the cosine of an angle is the adjacent side divided by the hypotenuse. So now if we fill in those three pieces, the cosine of 26 degrees is equal to the adjacent, which we need, so CD, over the hypotenuse, which was that number we had stored. So let's just put an A there in the box. Okay, so this will be the stored number on our calculator. Essentially, that's this 5.74. Okay, so when we go to actually do this, we need to remember that cosine 26, again, just a number. In order to get rid of this fraction, I'm going to multiply both sides by whatever that stored number was. In this case, it's that 5.74. So I'm going to actually do A, which was our stored number, multiply it by cosine 26, and that's going to give me the side length that I actually needed. So if we put in our value for A, multiply that by cosine 26, this should give me exactly what I need it to. And it gives me 5.16 and a whole bunch of other numbers. And we're asked to round that to the nearest tenth. So 5.2 centimeters is going to be our length of CD. Okay, so as you can see, there was a couple other things we had to think about. We had to use those trig ratios twice, and we used an answer again. So be very careful how you label those triangles, because since we're using the same answer in another step, if the first step goes awry, the rest of it also falls apart. Okay, so just be very careful, slow down when you're doing these, and make sure you're doing them correctly. Okay, the one underneath, very, very similar. You might just need to start looking at it a little differently. That shared side, again, is going to be what's important. Okay, so y to w, that'll be the side we have to find first, because in the triangle y, w, z, I have an angle and a side length. In the smaller triangle x, y, w, I only have one piece of information, an angle. I don't have enough to find that other side until I find the side that they share. So what we're going to do first is locate that shared side. Okay, so we're going to use our reference angle at 20. This will become our opposite side, the one, again, directly across from it. 8.4 then is across from that right angle. That's our hypotenuse. Okay, so we're going to use sine first to locate that shared side. So the sine of an angle is the opposite divided by the hypotenuse. If you fill the stuff in that you know, 20 is your angle. So the sine of 20 degrees equals that opposite side length, which we don't know. Let's just call it WY or YW, whatever you like. Hypotenuse is 8.4. Okay, we need to actually get that WY by itself. So again, you can divide by 1. My variable's on top. So we're going to do 8.4 multiplied with sine 20 and then divide it by 1. So what's going in your calculator is that 8.4 multiplied with sine 20 degrees. That'll give us our WY. Let's get that back to purple. Okay. So if we do 8.4 sine 20, enter, that's going to give us 2.87, a whole bunch of stuff. So we need nearest tenth for now, but again, we're going to have to use this number somewhere else. So let's just say it's 2.87, a whole bunch of other numbers, and that's WY. So we're actually going to store this into our calculator. We're going to call this that A with the box again. So we're going to put that in for A. So just like last time, we're going to press store, and we're going to store it in the bin for A. So if I had something in there before, this will override it. Now if I just test it out first, alpha, and then math, that'll bring up my A. Test it out, you do have the same thing. So it is stored. Okay, so the next thing we have to do is actually figure out what we need to find. We're asked to find here XY. Okay, so in our original picture, I need this purple side length, X to Y. If I have a right angle along a straight line, like I do in purple here, I also know that the other angle should also be a right angle. Okay, so now I know what this opposite side was. We just found it. It was 2.9 if you round it, but we're using the stored value, so that's our stored value of A, so I know that. 22 is our reference angle. If I need to find XY, I'm really looking for the hypotenuse. Now, if 22 is our reference angle, that would mean that the stored value of A, that's going to be our adjacent value. So we're actually going to use cosine on that small triangle. So if we used our cosine formula, which is adjacent over hypotenuse, we're going to use that with the cosine of 22 degrees. The adjacent side is going to be our stored value of A. And we're going to divide that by the hypotenuse, which we said was xy. That's what we tried to find. Okay, again, underneath, you can divide that by 1. And you can cross multiply and divide. Since your variable's on the bottom, this time we're going to have to take our stored value of A, multiply it with 1, divided by the cosine of 22. Let me move some stuff around here. Let's put that up there, give us a little bit of space. Okay, so we're going to have to take our stored value of A, divide that by the cosine of 22 degrees. That will lead us to the final answer that we want. So in our calculator, A was our stored value, so let's bring that up. We'll divide it by the cosine of 22, close the bracket, and there we go. There's how big xy is. Now to the nearest tenth, we should be rounding this, so that'll be 3.1. It is centimeters, and that's xy. So again, 2 steps. As long as you find that shared side first, you can use it in the other triangle to find what you need to. Okay, let's look at more of a problem-solving approach. So for those ones, I kind of just gave you a picture and said, away you go, find the thing that's missing. Okay, here's a bit of a more problem-solving type question. Sometimes you're not given the picture and you're going to have to draw them. This one does have a picture provided. So it says, from the top of a 20-meter high building, a surveyor measured the angle of elevation of the top of another building and the angle of depression of the base of that building. Surveyor sketched out a plan of the measurements, determined the height of the taller building to the nearest tenth of a meter. Okay, so here's the picture that we've got to work with. I believe all the measurements are in there, so there wasn't anything from the question that was missing. I have an angle of elevation, I have an angle of depression. Here's the height of the building, 20 meters. So pretend that somebody is standing at the top of this building. Maybe red's not the best. Maybe blue's a little better. Okay, somebody's standing at the top of that building. Now their eyesight is going to be that dotted line looking straight across. When they tilt their head upwards to look at the top of that building, that creates an angle. So there's that angle of 30. Now if they're in the same position, they're looking out horizontally, then they look down at the bottom. That head tilt creates that angle of depression of 15. Okay, they're 20 meters above the ground, so that's helpful. Now I've got to figure out the height of this taller building, was essentially my question. Now, if this building that they're standing on is 20 meters, that 20 meter height transfers all the way over to the other side as well. So part of our job is actually done for us. That's 20 meters right there. I know what part of this height is. The only thing I really have left to do is figure out what this missing piece is. Let's give that a name. Let's call it x. Okay, that's going to be our missing height. So using this information, I should be able to find that. Now the thing, again, that I'm going to need to find first is that shared side. Okay, if I just look at the 30 degrees and the x, I don't have enough information to do anything yet. But in this smaller triangle at the bottom, I know I have an angle of 15. Its opposite side is going to be 20. We can go ahead and find its adjacent side. So let's label that. That's going to be adjacent to this angle. 20, that'll be our opposite. Okay, so let's go find that first. If it's opposite and adjacent, that's going to be tangent. So the tangent of an angle is its opposite side over its adjacent side. That means the tangent of 15 degrees is equal to 20 over that adjacent side. Let's just call it adjacent. Okay, tangent 15, just a number. You can divide by 1. Take 20, multiply it by 1, divide it by tangent 15, that brings you to your adjacent side. So you're going to do 20 divided by tan 15. That's equal to your adjacent side length. Now let's go find out what that is. So 20 divided by tan 15, close that bracket, 74.6. So again, we do have to use that number elsewhere. So let's store it again. Okay, so let's just write down part of it, 74.6. And we're going to take that and we're going to store it as A. Okay, so let's store that into the calculator as A. There we go. So we can pull that number up whenever we need it. Now in my other triangle, zoom back in there, I now know that this adjacent side was that 74.6 number. So now I've got an angle of 30. I know the opposite side is x, but that 74.6 is still the adjacent side according to this 30 degrees. So we're going to use tangent one more time. So tangent of an angle is opposite over adjacent, which means the tangent of 30 is equal to that opposite side, which we called x, divided by that adjacent side, which is our stored value from before. So here's my stored value. Okay. That's again tan 30. Don't need to inverse that, just divide it by 1 in order to get rid of that fraction to get x by itself. Multiply by your stored value on both sides. So you're going to take your stored value and you're going to multiply it by the tangent of 30 degrees. And that'll give you the missing part there. So if I take my stored value of x, or stored value A, multiply that by tan 30, enter, that missing height of that building is 43.1 meters is what we could do. So let's take a couple decimal places. 43.094. That's going to be x, that's meters. Just so we have to use that number one more time. So if we take a couple decimal places, it gives us the most exact answer we could get. So if I take that height, which is partial height of that big building, and I add 20 to it, that was the piece from the bottom. It's just one more step we have to take care of. If we take that 43.094 meter number, add 20 to it, that will give us our total height to the nearest tenth of 63.1 meters. So that's going to be our total height. Okay. So this one, a couple extra steps to think about. So just remember how to store that number on there. If you're not sure how to store it on your calculator, you could use 4 or 5 decimal places. That would give you an exact enough answer also. And just remember to add that 20 to it that was on the bottom piece. Okay, part B, another similar type of question. So I'm not going to solve this one for you. I'll let you try that one on your own. And again, you have that answer key to double check it when you have a chance. That's basically the end of trigonometry. So I hope that went okay. I hope that went well. If you need to, pause the video, rewind, do whatever it is you need to. And we'll see you in the next unit.